Hello, I'm Lisa Van Dusen, and welcome to First Person. I'm here today at Google with Jeff Dean, who is Senior Fellow at Google Research, one of two, and he is working on deep neural networks, among other things, and I'm excited to learn about what you're working on right now and why, and also what you're most curious about and what is most fun.
The main thing I'm working on right now is a kind of machine learning, essentially teaching machines to learn things and then using that kind of approach to solve lots of different interesting problems that have traditionally been pretty hard for computers.
So what are some of the terms? I've heard deep learning, machine learning, deep neural networks, Google Brain.
Sure. So machine learning is a broad term meaning the notion of allowing machines to learn from observations about the world, typically from different kinds of data, like images or like reading lots of text, and then learning about that so they can generalize to other situations. Neural networks are a particular kind of machine learning model. It's sort of loosely inspired by how we think real brains behave, but only at the very kind of abstract level. There's a notion of sort of neurons that are connected to other neurons, and they take in input signals and maybe fire, and you can emulate that in software. But it's not sort of simulating at the biomechanical level like what's going on, or biochemical level. It's more of a very abstract, loose notion of just trying to behave in a similar way to how brains behave.
So what about that is fun to you, and why does it matter?
Sure. So I think one of the things that's really interesting is traditionally processing perceptual inputs, things like images or audio input for computers has been pretty hard. Speech recognition has been a pretty challenging problem. Understanding, if you show a computer a photograph, what is that actually a photograph of? And in the last few years, people have been able to use neural networks, in particular, neural networks trained on a lot of data using a lot of computation, to actually solve some of these problems in ways that 5 years ago you would have said, there's no way a computer can do that. And now it can do some pretty cool things.
So recognizing a tractor and knowing that that's what that is, even if it's a different
Right,
kind.
yeah. So, understanding what's in an image, you show it an image and it says, okay, that's a person and there's a dog next to them and there's a couch. There's even some models that can take in an image and then write a human level sentence about that image. So it might take an image and it might say a close-up of a young girl holding a teddy bear.
So I know, for example, I've seen that there's something called a cat detector. Is that right?
We process YouTube data, so of course there's a cat detector.
Is there a dog detector also?
Yes, okay. But not as strongly trained, because YouTube videos are all about the cats.
That's right, seems to be. So going backwards in your life, was there a particular person or experience that was during your formative years that was important in shaping your path?
In terms of?
Taking you where you are now.
So I think one thing that's interesting about my childhood is that I moved around a lot. My parents ended up just moving around. So I went to 11 schools in 12 years. And about my middle school years, my dad got interested in computing. He's a medical doctor, but he was always kind of interested in how to use computing to sort of improve public health. And so he saw an ad in the back of a magazine for a kit computer. This was kind of a year or two before the Apple II came out. So this was very early in the days of personal computing, and he bought this kit and he kind of soldered it all together. And I kind of I was 9, so I kind of helped as much as I could, or mostly I got in the way probably. And so I kind of started to just use computers. It was kind of a natural thing to me, although at that time, it was a very rare thing to have a personal computer, and now it's, very common for everyone to have a computer in the US anyway. So I just kind of grew up fiddling with computers and writing software, and I would get game programs and I would type the software in, and then I would play the game and I would modify it a little to kind of make a slightly different game, and that's just kind of how I tinkered.
And you lived actually in Africa for a while.
I did, yes.
I don't know if that played into things.
So I lived in Uganda when I was 5. That was before we had a computer. And then we spent 6 months in Somalia when I was 13. And we actually brought a computer in 1981 to Somalia. It might have been the first computer that went into Somalia.
Are there any kind of intersections in your life? I mean, you're going along where you feel like, oh, if I'd gone that way, this would have happened. But key choice points, kind of, since all that tinkering.
So when I finished undergraduate, I double majored in economics and computer science, and I was kind of pondering which of those I should go to grad school in. And I ultimately decided I liked computing more, and it was more practical. So I mean, that was a choice point. One of the things I really like about software is that you can get a small group of people together, and because software can be replicated or used now over the internet so readily, you can have a small group of people build something that is used by a lot of people.
What about your daily practices? Are there things that you do every day or most days, and particularly that sort of ground you or that really set you up for a great day?
So there's a group of us at Google. Actually, some of us worked together even before I came to Google. So we've been working together for almost 20 years now. And every morning at 9:07, whoever's there, we go and make cappuccino together. So there's, sometimes 3 or 4 people, sometimes 8 people, and we each have our own roles. So I steam the milk, someone else grinds the espresso beans and loads them in the espresso machine. Collectively, we've made 16,000 cappuccinos, I think.
How would you describe those early days, and how can you describe how things are different or maybe even the same in maybe some of the less obvious ways now?
Sure. I mean, so in the early days, when I started, we were wedged in a little office above the T-Mobile store on University Avenue in Palo Alto. And, things were very frantic because we had a fair amount of traffic, like requests per day, queries per day. And we continuously needed to deploy new computers to keep up with that traffic growth. We were also trying to increase the size of our index so that you could search more pages, and also use sort of more complex algorithms, which were more computationally expensive. So all of that together meant we needed to deploy computing hardware as fast as we could. We also needed to improve the efficiency of the software kind of every week pretty much to avoid melting the following Monday when the peak traffic would happen for the week after that. And that was like very exciting and like dynamic. You're like, oh, we got to get this done. So that was pretty fun and interesting. And obviously now Google is a much bigger place. We have a lot more different kinds of products and things we're working on as a company. And that's great. It's very cool because one of the things I really like about being here is that often you work together on projects where people bring different kinds of expertise, and collectively you kind of work on something that none of you could do individually, but together you can actually learn from each other and also accomplish what you're trying to do.
I've heard about the grand challenges of the 21st century from the National Academy of Engineering, and things like making solar energy economical or developing carbon sequestration methods, and a list of 14 or so. And I'm just curious about, and some of those, some progress has been made, obviously. Reverse engineering the brain, that's one. So could you talk about those and how what you're working on is or maybe isn't addressing some of those challenges?
Sure. So, the National Academy of Engineering is engineering advisory board for the U.S. government, and they put out this list of challenges of things that engineers in the U.S. Academy felt were important and were sort of things that should be worked on and would really make a big difference in the world if we could make progress on them or solve them. And some of them are kind of more traditional engineering things, like the solar energy thing is very much a material science kind of challenge. And an awful lot of them actually are different kind of subfields of engineering or science that can be pretty heavily impacted by computing and machine learning. So these are things like improving the quality of healthcare. That I think is an area that's ripe for, using lots of machine learning and understanding of, past outcomes and things like that. Let's see, other ones were, it's a long list.
Well, there's engineering better medicines, and then health informatics in that space. Just scientific discovery. That's kind of a wide open one.
Yeah, I think one of the things that computing can really help with is giving you some way to automate hypothesis generation and saying, well, this seems interesting, maybe we can explore this, and then humans in collaboration with computing can actually devise the right experiments to determine if those hypotheses are actually correct or not.
Yeah. So it sounds like you're creating the tools that can then, go in any of these directions.
Yeah, I think one of the really neat things about machine learning these days is it's really transforming a lot of different fields. So like the work that's being done on computer vision is very impactful in sort of building systems where computer vision is going to be incredibly helpful. So things like self-driving cars basically wouldn't be possible without computer vision, and now they're starting to become sort of more possible. The field of robotics, I think, is a really important thing. If you liken, 5 years ago, computers kind of couldn't see very well at all or very dimly. And now all of a sudden they can open their eyes. Like this is sort of like the moment in evolution when creatures developed eyes.
Right.
And all of a sudden there was a big change in the world because now you had the ability to see what's around you and to perceive things. And I think that change is starting to happen in computing.
Switching gears a little bit, you're here in live in Palo Alto and work in Silicon Valley. And what difference do you think that makes, if any, that you're here?
Well, I think Silicon Valley is a pretty magical place for people working in software or the computing industry in general, just because there's so much stuff going on. You drive up and down 101 and there's like lots of different companies. There's, very large tech companies. There's all kinds of startups, scattered everywhere throughout the valley. And there's like lots of people who through, work connections or things like that. And I think just having that concentration of people in this field is obviously what attracts more people to come to Silicon Valley, and that kind of builds on itself.
I understand that there's a vast collection of Jeff Dean jokes. Would you like to comment on that? And do you have a favorite?
Yeah, there are some jokes. They're sort of like, it was an April Fool's joke gone awry, actually, by some of my colleagues who hope to remain anonymous, but I found them through the status pages they left up on their server. Yeah, it's kind of funny and flattering. Some are like, Jeff Dean's keyboard only has 2 keys, 0 and 1. Or one of the things you can use in software to understand performance is a thing called a profiler. And so most of these are kind of computer science related jokes.
That's okay.
So one of them is like, when Jeff fires up the profiler, loops unroll themselves in fear. So a loop is a particular kind of software, and one way you can make it faster is you can unroll it, which means you make 4 copies of what the body of the loop is doing instead of 1, and then the overhead of like going back to the beginning of the loop is reduced by a factor of 4.
What do you wish people knew about you?
I don't know, that I'm generally a nice person.
And what would surprise people about you?
So what would surprise people is I have genetically almost no taste buds. So
and how does that play out in your life?
So it turns out I've always liked really extreme flavors in my food. And then I did 23andMe genetic testing, and it said, oh, actually, you probably can't taste spicy things, sweet things, sour things, or bitter things.
And what do you wish you had time to do or to do more of?
Learn about other scientific endeavor.
Anyone in particular?
I think the fields of genetics are really interesting. I wish I knew more about, the engineering of space vehicles. I don't know, there's all kinds of things.
Yes.
So I read a lot of kind of nonfiction books that are not sort of textbook things, but kind of fluffier than that. But I wish I had more time to really study those things in detail.
Do you consider yourself an outlier? And if so, in what ways?
No, not really. I think one of the things that I'm reasonably good at is understanding at a superficial level several different things and putting the connections together between things I know about and things I superficially know about. So that's something I do reasonably well, but I don't think I'm anything particularly special.
Well, that's interesting. So to the point of the applicability of what you're doing to all these different fields and your interests actually in these other scientific endeavors, it's kind of that in a way is your...
Maybe another way of saying it is I like to dabble.
Well, it seems like it's done good things. So thanks for talking with me, Jeff.
Sure, thank you.